Guys, here we go. Velocity and other rates of change. So we're already getting into like implicit differentiation. We're going to be taking the derivative with respect to specific values or specific variables. We kind of already know this, and don't worry. Hopefully, most of this will be kind of like a review. So again, it's the same definition that we've been working with all this time. And it says letter A, find the rate of change of the area A of a circle with respect to its radius R. So that means, what does that mean? That means that we're taking a derivative of A, but not with respect to X, with respect to R. So that's dA dr. Before we find this dA dr, do we know what area of a circle is? What's the equation? No, not 2 pi. Pi r squared. Yeah, pi radius squared. Are we okay so far? All right, so here we go, guys. I'm taking the derivative of A with respect to R. So I'm going to write dA over dr equals, I move the 2 to the front, 2 pi r. And I guess you can write dr, but you don't need that. And there it is. I took the derivative of A with respect to R. I guess, I don't know, maybe I should dr. No, but dr is really just 1, right? So do you need it? No. But I guess if you want to, if you want, Chop, what are you doing? Okay, let me go ahead and rewind. It's kind of like chain rule. It's kind of like you have that r by itself like that, see? And I'm taking the derivative, 2 pi r, and then I took the derivative of r with respect to r, dr. Does that make sense? So usually you just write it 2 pi r. 2 pi r. And that's it. You're done. You just took the derivative of area with respect to r. How do we feel? Okay, and then it says evaluate the rate of change of A at r equals 5 and at r equals 10. All right, so you write it like this. dA dr evaluated when r is 5 equals 2 pi times 5. So that's 10 pi. And let me write the other one. dA dr when r equals 10 equals 2 pi times 10. I'm just using the formula, guys. So 20 pi. How do you feel? Okay. If r is measured in inches and A is measured in square inches, what units would be appropriate for dA dr? I don't know. What do you think? Inches squared per? Yeah. Good job. Inches squared per, or square inches per inch of radius. Chop, I don't understand what's going on at all. Guys, this is just like the difference in area. Well, the difference in area is in square inches. And this is your difference in radius, which is just in inches. See? It's like a delta y over delta x, kind of. But remember, the reason why it's a differential is because we're talking about really small quantities of change. What's up? When you write it like that, don't. No. Because this is square inches per inch. So it's describing how much your area is changing per inch of radius. So don't cancel out the units. You gonna bring it back? Yeah. Okay. How many are you guys taking? Okay, take them. You can just take the you could have just taken the whole tray. All right. Don't cancel. Do we see where we're not canceling? Because we're measuring the quantity change of area per inch of radius, so we're not canceling anything. We're okay, guys? All right. I think we're good, guys. I think we already kind of know this. Instantaneous velocity is the derivative of a position function. Think about it. If you have a position time curve and you're finding a tangent line, what does the slope give you? Well, the slope's going to be the change in position divided by time. So that is velocity. Does that make sense? I'll say it again. So if you have a position time curve, so I don't know, like meters and seconds. Yeah. And you found a slope. Look at what that's. You found a tangent line, and you find this tangent slope. Well, the tangent slope is a change in meters over the change in seconds. Well, look at the units, meters per second. Isn't that just Yeah, it's velocity. Do you guys see that? So it's telling you here just verbatim that if you take the derivative of a position, that you get velocity. See, ds dt, that's just this, and you get velocity. And then it just says here speed is the absolute value of velocity. I don't think that's any. Don't worry, we're gonna talk a whole bunch about this. And then what do you think the derivative of velocity is? Acceleration. Because think about what if you have a velocity time curve, so velocity in meters per second and time in seconds, and I have a curve, and you find a tangent line. Look at what your slope is. Change in meters per second over change in seconds. Well, that's meters per second, which is meter per second squared. Do you guys see that? So the derivative of velocity is acceleration, and that's what they have here. dv dt is acceleration. There is something else. There is one more on top of this, the derivative of acceleration. What do you think that's called? Take a guess. Starts with a J. A jerk, yeah. You've probably seen it on T-shirts. No, never. So if you want to be mean to your boy or your girl, we don't judge here. Say you're the derivative of acceleration, and if they go, I don't know what you're talking about. You're confusing me. Go look it up. That's what you are right now. And when they Google derivative acceleration, they're gonna say jerk. Like, oh, she's calling me a jerk, but she's just a big nerd. Okay, you know. So there it is. If your boy or girl's being mean to you, call them a derivative of acceleration, and you're calling them a jerk. And if they ask, I don't know what that is. Like, go look it up. Go Google it. I'm gonna go tell that to Jocelyn. Yes. Well, okay. Don't tell her that. Acceleration due to gravity, guys. If you're talking about English units, you're going to say 32 feet per second per second. If you're talking about metric units, which the whole world uses metric, you're going to talk 9.8 meters per second, or 9.8 meter per second squared. Usually you want to say negative because downward is negative, but not a big deal. You guys want to see a problem in action that looks like a physics problem? Okay, let's go to the next page. All right, check it out. A dynamite blast propels a heavy rock straight up with a launch velocity of 160 feet per second. It reaches a height of s equals 160t minus 16t squared feet after t seconds. How high does the rock go? By the way, guys, this formula comes from somewhere. Do you guys remember when you guys had winds and wind said velocity initial times time? This is not VI respective time plus 1/2 AT squared. Do you guys remember that? All right, well, check it out. Velocity initial, in this case, is 160 feet per second. So this VI is that, and this is times time. And then the acceleration due to gravity, we're using this one, but we're going to say that down is negative. Down is negative. So negative 32 feet per second squared. If I plug in the 32 in there for A, what's half of 32? Well, look, that's where this came from. So I don't want you to think that these formulas are just magically appearing. They come from somewhere. See, so if you knew calculus last year with Wentz, you could have just plugged in your velocity initial, your acceleration, just done derivative, and do all these problems with just that. You guys ready? We're going to go slow. How high does a rock go? Well, I don't know. Here's my rock. Well, pretend it's a rock. That's not a rock. Okay, so give me a rock. How high does it go?
10 meters.
Well, tell me something what's happening at the very highest point.
It's stopping.
Yeah, at the very highest point, it reaches the velocity is 0 at that moment. Does that make sense? So here's what I'm going to do. I'm going to take the derivative. I'm going to equal that derivative to 0 because I'm saying that's where my velocity is 0. And then whenever I solve for time, I'm going to plug that into my position, and I'm going to find out how high it goes. Do you see the game plan, guys? All right, so here we go. How high does the rock go? I'm gonna put rules here. Find where velocity is 0. Find time. Find time. There's my little caret. Find time where velocity is 0, period. All right, I'm taking a derivative. So I'm going to say this. What am I going to say? I'm going to go ds dt, which equals velocity, equals, what's the derivative of 160t with respect to t? 160 minus, what's the derivative of 16t squared with respect to t? Negative 32t. And I'm gonna equal this to what again? 0. I'm equaling my velocity to 0. Is everyone okay? All right? Yep. I'm going to go 32t equals 160. And then just like Miss Houston said, divide by 32. T equals 160 divided by 32. I want to say that's 5, but let's take our calculator here. It is 36, 91, 120, 36 and 90, 120, 2, 4, 6, 8, 10. What did I say I was going to do? 160 divided by 32. 160 divided by 32. Bam, 5. Okay. Now that I know that t equals 5, I'm going to take this 5, I'm going to plug it into the original. S of 5 equals 160 times 5 minus 16 times 5 squared. And this is going to tell me how high off the ground it reached. What's up? What? Oh, it's not negative because I moved it to the right-hand side. And then I wrote it. See, I just did this. And then I wrote it on the left-hand side. You know what I mean? All right, here we go. 160 times 5. Yeah, keep asking me questions, guys. Hit me. I mean, don't hit me like physically. Minus, I want to live, guys. I want to live. 16 times 5 squared. And there it is. I'm 400 feet in the air. Or 400, what was this? Yeah, 400 feet. So units, I'm going to say at t equals 5 seconds. Or I get, how high does the rock go? The rock goes 400 feet up in the air.
Can you explain why we're setting it to 0?
Yes, because when the rock reaches the highest point, the velocity is 0. So I found where the velocity was 0. Okay. You guys ready? All right, letter B. What is the velocity and speed of the rock when it is 256 above the ground on the way up, on the way down? Okay, on the way up, I'm going to get a positive velocity. On the way down, I'm going to get a negative velocity. It's symmetrical, so I'm probably going to get... All right, well, what are we going to do first? What is the velocity and speed of the rock when... Okay, see how they want me to find out when it's 256 feet? So what you're going to do, take your position equation, S of t, and we're going to solve for when it's 256. So I'm going to go 160t minus 16t squared equals 256.
250.
Are we still okay?
Yes.
Move the 16t squared and the 160t to the right because I like to have the 16t squared positive. So I'm going to write 16t squared minus 160t plus 256 equals 0. Yes, we're going to factor. Factor out a 16. And you're going to get t squared minus 10t plus, I want to say 16. Isn't 16 times 16, 256? Let me make sure. 16 squared, yeah, 256 equals 0. Are we still okay, guys? Two numbers that when I multiply give me 16 but added up to negative 10. Perfect. T minus 8. T minus 2. So I get two values where this rock is at 256 feet. Try to guess, which one is the rock on the way up? At t equals 2 or at t equals 8? 2. And then t equals 8, it's going to be on the way down. Are you shocked that you got 2 and 8, by the way? No? Think about it. No? Do you guys know what I'm trying to say? Okay. Slow down. Time out. How long does it take for this rock to reach its highest point? 5 seconds. I did it in letter A. So if it took 5 seconds to reach the highest point, it takes another 5 seconds to reach down. So as soon as so it's in the air 10 seconds, assuming that wind resistance is negligible. So it's in the air 10 seconds. So at 2 seconds, it's at 256 on the way up, and because it's symmetric. At 8 seconds, 2 seconds before landfall, it's on the way down. Because it's symmetric. Right at the t equals 5. Do you guys know what I'm saying or no? No? Okay. Houston, check it out. Don't worry. Bless you squared.
She didn't say she didn't understand.
No. You're brave. Please.
Why it's 8.
Okay. Because it's on the air 10 seconds. It's in the air for a total of 10 seconds. So it's symmetric right at the 5 second. At the 5 second mark, you're at the highest. At the 2 second mark, you're on the way up. Because it's symmetric, at the 8 second mark, you're on the way down because it takes 10 seconds to go down, 10 seconds to hit the ground from liftoff. Does that make sense, guys? So there's my little picture. It probably just went straight up and straight back down, so it actually didn't curve like that. But I just did it just to make life easier to understand. Cool or not cool? Yeah, don't worry. Relax. You're good. Like if we don't understand that, that's fine. Uh,
I'm confused.
yeah.
Okay, so you said that isn't t equal to time?
Yes. I haven't found
We're
the
not
speed
done
yet.
right?
No,
Not
no,
done?
no,
Okay,
no, no.
because I was like, I'm confused. Why
Okay.
is it
Here we go. Ready? I'm gonna find my velocity. I'm gonna write v of 2 equals, and here's my velocity equation right here. 160 minus 32 times 2. So 32 times 2, 64, 96. 96 feet per second. All I did was 160 minus 32 times 2. And I got that. Cool or not cool? So there it is. What is, bless you, velocity at 8. Okay. Before I do this, velocity at 8, if I plug in an 8, I better get the same magnitude, but instead of a positive, it's going to be negative because I'm on the way down. Does that make sense to you guys? This is symmetric. So 160 times 32 times 8. And let's see what this is. Not all problems are going to be symmetric, guys. This one, they're just being nice to us. 160 minus 32 times 8. Close, enter. Negative 96. There you go. One's on the way up, one's on the way down.
How do you know if it's gonna be symmetric?
Okay, good question. When this dynamite blast happened, I was here at this position at 0, and I come back at 10 seconds later, and I'm back at that position at 0. That's how I know it's symmetric. If I would have blasted it like 10 feet off the ground, and then the rock hits the ground, then it's no longer symmetric because I blasted it 10 feet above the ground. What's up?
Why did we plug it into the
Because they wanted to know the velocity. What is the velocity and speed of the rock? So velocity is the derivative of position. Do you know what I mean?
And then the derivative velocity is acceleration.
Yes. Check it out, guys. What are you going to tell me? Are you going to tell me that the speed of the rock at 8 seconds is negative 96?
No.
No, speed is always positive, the absolute value. So I'm going to write a sentence. Speed of rock when it is 256 feet above the ground on the way up and down is, okay, speed of rock when it is 256 feet above the ground on the way up and down and is 96 feet per second. So let me read it again because my handwriting sucks. Speed of the rock when it is 256 feet above the ground on the way up and down is 96 feet per second. There it is, full credit. Does that make sense, guys? All right. Letter C can be answered without calculus. What is the acceleration of the rock at any time t during its flight? It's the acceleration due to gravity, which is always, we're in English units. So we're in English units, acceleration is always 32 feet per second per second. But let's do it with calculus.
Will they give us this number or do we need it?
We should know it, like 9.8. So let's see, what was my velocity? My velocity was what was it? 160 minus 32t. And here it is. dv dt, which is equal to acceleration, is equal to negative 32. Are you shocked that it's a negative 32? No, the negative gives direction, guys. Feet per second, or feet per second squared. I like this one better. Okay. If you're a physics person, you'll probably like the feet per second squared. What's up?
You know it's the English version because it has feet in it.
Yes. Plus, they told me right here. Yeah, 160 feet per second. So I know that we're in English.
Does it matter which?
You could have said 9.8 meters per second as long as you put the right units. We could have easily. Now, if you just put 9.8 blank, we're going to assume that you're talking feet per second, and it's going to be wrong. Okay? All right. When does a rock hit the ground? Well, okay, I'll show you with algebra in a little bit. But if it takes 5 seconds for me to reach the highest point, it's going to take another 5 seconds for you to reach the ground. So when does the rock hit the ground? 10 seconds. Rock hits the ground in 10 seconds. Okay, let's prove it without just doing it by that. My position formula, and I already forgot what it was. There it is. 160 t minus 16t squared. 160t minus 16t squared. There's my position. Anyone need to take a picture? All right. Factor out a 16 and a t. If you factor out a 16t, look, you'll get your 10 seconds right here. What's this? It's going to be 10 minus t. There it is. So you get t equals 0, which we're not shocked. That's the moment that the blast happens. And t equals 10 if I equal that to 0. Does that make sense, guys? And there it is, guys. How do you guys feel? Do you see how useful this is? What's up?
Can you go back to C? I don't understand why 32 is negative.
It's negative because we're saying that down is negative. So the acceleration due to gravity is pulling it down. Or you can just take the derivative of this. Look at this. I'm taking the derivative of velocity. The derivative of 160 is 0. The derivative of negative 32t is just negative 32.
So then,
Ask me. Go ahead.
how come it's just positive x? It's just
Oh, they're just telling you the value of what the gravity is. So see how, look, right here you have a positive 9.8, but if it's acceleration due to gravity, we're always going to count negative 9.8. You know what I mean? Okay.
it's always going to be that.
Metric 9.8, English 32. Yes. Oh yeah. When you're deriving your formulas from scratch, which you won't, but if I tell you the initial velocity and the acceleration, that's how you do it. There is a question on UH where you have to derive your formula from scratch, but they're not on the AP exam. They're just going to give you the problem because we're not trying to test to see, we're trying to test to see if you know calculus, not if you can derive equations. But it'd be nice if you could do this from scratch. What's up, Miss? U Chicago will probably want it. If you take calculus at U Chicago, they'll probably won't give it to you, and they'll probably want you to derive it from scratch.
So if it wasn't that equal, then we would have to do it to algebra to find.
I didn't hear anything you said.
If it wasn't symmetrical, then you do the algebra to find how long it takes to ground.
Yeah, you could, but only if it see on this one it was symmetrical. At my initial height, that was the blast. But if it tells you that my height of the blast was 10 feet above the ground, then you can no longer do this algebra stuff that we did. 5 seconds up, 5 seconds down. No, because because you didn't take off from 0, you took off from 10. If they tell you that, or the blast was 30 feet above the ground initially, and then it hit the ground. How long? You can't use symmetrical anymore. You know what I mean? Okay. Ask me. You got some questions more, Johnson? Hit me. Urabaso, you got some questions? Because you're going to be a future engineer, miss. Okay. Andrea Garcia Torres, you got some questions? Okay. All right, guys. Last example. Yeah, look, it's a short day today. Okay, ready? A particle moves along a line so that its position at any time t greater than or equal to 0 is given by the function. So we have a particle moving on a line. So imagine a horizontal line, and that's it. You're just moving right or left. Where s is measured in meters and t is measured in seconds. And here's the equation that tells me how I move. Are we still okay? Nothing crazy, right? Okay. Find the displacement of the particle during the first 2 seconds. Okay. Well, displacement is equal to my position at 2 minus my position at 0. Nothing crazy. We're still okay, guys? I'm going to come here to the side, and I'm going to go S of 2 equals 2 squared minus 4 times 2 plus 3. So let's see. 4 minus 8 plus 3. So negative 4 plus 3. I count negative 1 for that one. S of 0, I just see 3. All right, so here we go. I come over here, and I'm going to go negative 1 minus 3. So my displacement was just what? Negative 4. Negative 4 meters. Yeah, meters. Displacement, negative 4 meters. So what all that just means is between 0 and 2, you went 4 meters to the left. That's all it means. Are we okay, guys? Okay. Find the average velocity of the particle in the first 4 seconds. Okay, let me write the formula for average velocity. This is what you did in physics. Average velocity is equal to displacement divided by the change in time. You guys remember that from physics, right? All right, so here we go. If they wanted the first 4 seconds, I need S of 4. S of 4 equals 4 squared minus 4 times 4 plus 3. And I need S of 0. S of 0 is 0 squared minus 4 times 0 plus 3. So it looks like it is 0. Average velocity equals 3 minus 3, S of 4 minus S of 0, over the change in time, 4, 0. Meters, I don't have to spell it all out. Meters per second. I guess if it's 0, it can be any units. Right? Feet per second, miles per hour, doesn't matter. 0 is the only time that every unit's going to be correct.
Second square.
Say that again?
I see second square.
Oh, it's velocity, not acceleration. You know, Yanni, that's demerit. I'm gonna make fake demerits. Just like you guys made fake demerits, I'm gonna make fake demerits and I'm gonna start passing them out. Yeah, and then just different things. All right, here we go. Nothing crazy. And it says find the instantaneous velocity of the particle when t equals 4. Okay. They want the instantaneous velocity. So for that, I'm going to have to do a what? Derivative. Derivative of what? The derivative of, the t squared minus 4t plus 3. The derivative of position. T squared minus 4t plus 3. So here it is. Anytime you do any exam, show them where you got the velocity. So I'm going to write ds dt. If you want to put ds with a parenthesis t to show it's with respect to t, that's fine. But this is usually you just go ds dt equals v of t, which equals 2t minus 4. I'm taking the derivative with respect to t. Are we okay so far, guys? All right, here we go. I'm going to plug in a 4. So v of 4 equals 2 times 4 minus 4. So 8 minus 4 is 4, and then put your units, meters per second. And there it is, right at the 4-second mark. It is 4 meters per second, not to be confused for the average velocity, which is what you did all the time in physics. How are we feeling? Okay. Find the acceleration of the particle when t equals 4 seconds. How do I find the acceleration? Take a what? Derivative of which one? Velocity. So show them that. So go dv dt, that's derivative of velocity with respect to time, equals a of t. There it is. So I just showed them that I'm taking the derivative of velocity. Are we cool? Equals, what's the derivative of 2t minus 4? 2, just 2. And I'm going to put units. It's always 2, so this is going to be 2, what was it, meters? Meters per second per second. Oh, you guys are physics people. Meters per second squared. That's fine. Are we still okay? All right. No, don't worry. We're going to be fine. We're going to be fine. At what value of t does a particle change direction? All right. We're only talking about one-dimensional motion. You're either moving what or what? Left or right. So when all I got to do is see when the velocity crosses the x-axis when it's 0. Does that make sense? So there it is. So where's my velocity equation? So I'm going to write v of t equals 2t. And don't worry, I'll give you a visual because I know some of you are visual. 2t minus 4, I'm going to equal that to 0. And I'm going to go 2t equals 4t equals 2. So sometimes this is what we do, guys. We call that a 0. And let me do, here's my velocity, curve, velocity. And I'm going to put a 2 here, and it goes forever to the right. My domain is all numbers greater than equal to 0. To the left of 2, I'm just going to plug in a number like a 1. Child, what are you doing? I'm just plugging into this. All I care about is positive or negative. If I plug in a 1, 2 times 1 is 2. 2 minus 4 is a negative. I have a negative. Do you guys see that? Yeah. The sign chart. If I plug in a number like a 3, relax, you're fine. If I plug a number like a 3, 2 times 3 is 6. 6 minus 4, is it a positive or negative number? Positive. So here's the right way to say it. You say the particle changes directions. So let me get rid of that. The particle changes direction at t equals 2 seconds since velocity changes signs at t equals 2. Does that make sense to you guys? In just plain English. What's up?
So you equal it to 0 because that's the x-axis?
My domain is t greater than or equal to 0.
Oh, okay.
You know what I mean?
What if it's a different number?
Then we would say the different number, right?
Then you equal it to like the number that I gave you.
What do you mean?
It's like when we equal it to 0.
Well, I equaled it to 0 because that's the only way that. Okay, let me draw a visual. So here's that visual. It's not for letter D. It's a visual for letter E. So here's my visual. This is my velocity. Here's my time. Are we still okay? I have a y-intercept of -4, and it looks like that. And it crosses the t-axis or the x-axis at 2. Notice that to the left of 2, my velocity is negative. So that means I'm moving left from 0 to 2. And then after the 2 seconds, the velocity is positive. So now I'm moving to the right. So what is the change of direction? Well, when I move from left to right. Where do I move from left to right? At t equals 2. And that's what I said. The particle changes direction at t equals 2 seconds since velocity changes sign at t equals 2. Does that make sense? Okay. How do we feel, guys? Do we feel okay? Okay. I didn't assign any new homework. There is no new assignments just yet. Any new assignment that I give you guys will be for next 9 weeks. Tomorrow I will assign some new stuff for you guys. Today I just want you to practice with your exam. Only like 3 of you have done that. So I'm not changing the exam, guys. It's literally the same one, except it's going to change the numbers for you. No. And that's it. We're done for today.